Now we're on 12. All right. Somebody that can read really loud needs to read me the first question on 12.
Photocell uses a light to change resistance.
Does it? Does the photocell use light to change resistance? Does the photocell use the light to change resistance? I don't know what that is. I've got somewhere here. Oh, here we go. In this little box of goodies. I always like to pull this out and wave it around when I'm teaching this. I've got a photocell. All right. This is a photocell. Hello. Some of you guys have saw this before. I've also got some LEDs in here. All right. Now this one right here. See that little photocell? That little photocell right there. Now I can take this meter right here. This meter right here. Because this is what teachers do, you see. And I'm going to put this. I'm just going to put this on a couple of thousand ohms right here. All right, I'm going to hold one to that and another to that. All right, you see this? Come here, somebody. Wes, come here and hold this meter. Come here and hold that meter. Hold it so that the guys in the camera can all see it. All right, now then, you see that right there? See that reading? All right, now I'm going to cover this up with my chin. All I'm going to do is block the light. See?
That's pretty
You lost connection.
No, I didn't lose connection.
It changed resistance because of light.
Lack of light.
Yeah, see, and the more light you shine on it, the more continuity it has. You got that? So
That's like the light thing in the top of your dash.
There you go. That's how a photocell works. But now the thing on the top of your dash is connected to some other electronics, and they respond to what the photocell does. So that is a photocell. That's how that works. So that's one of them. I mean, I've had that there for a while to show whenever we talk about photocells. All right. Fiber optics are used in areas where bulbs would be inaccessible for service.
True.
Yeah. Well, it was funny to me. Yeah, that's true. But what I was going to say was, on the old International trucks that were made back in the 70s, all of the little words above the knobs on your dash that lit up at night, every single one of those, and they were all over the dash, you know, for this knob and that knob and the other, they had a little, you know, cool little words there. Every one of them was lit by a single little bulb. And the way that they did that, and you know, most people didn't think much about that, they just went on about their business, but when I was looking under the dash, and I saw something under there, and I kid you not, it looked like a miniature flying saucer. Like that right there, except it was shaped a little different. And inside that miniature flying saucer was one bulb. And coming out of that little miniature flying saucer were all these fiber optic lines going to every single light in the dash. And if that one bulb blew out, every light in the dash would go dark. I'm talking about behind the speedometer. I'm talking about behind the knobs. You know what I mean? That was on the International Lodestar 1800. It was cool as all get out. And see, that's fiber optics.
I bet you somebody, if that one bulb went out and all that's light, the first thing somebody would check is fuse.
Yeah. Well, it was funny because you could look under the dash and just there it was, you know. And that was funny as all get out to me how they did that. And I don't know why. I don't know how many other people did that, but I mean how many other automakers did it. But International did that. Some smart aleck came up with that idea. A potentiometer is commonly used as a sensitivity control. That's true. Number 4, potentiometer is like, you know, throttle position sensor or one of these little. The throttle position sensor is a potentiometer, but the kind of potentiometer we're talking about is one that I used to have in there, but I don't know where it is right now. Maybe down in here. But it's just a little knob that's got 3 wires connected to its little piece on the inside. And I'll tell you something else, guys, and this is something I teach and I show, is I can take a potentiometer and dial up and down, hook 2 legs of it up to where a engine coolant sensor hooks up, and I can change what that PCM is seeing for engine coolant temp. It's cool to do that. Let's say somebody tells you the fan's not working on your vehicle, whatever vehicle it may be, and you get like a 50,000 ohm potentiometer, hook just two of the leads of it You know, it's got to be one of the ones that, you know, the middle one is actually typically, you're going to hook it to the middle one and one of the outer ones, and when you turn that knob, you can watch that temperature change on your scan tool. Crank the car up, dial it down to where the scan tool thinks, where the PCM thinks the engine's hot, see if the fan kicks on. You can do that while everything's still cool. And it works really neat. I did that. I mean, I started doing that ages ago over there. I just get a potentiometer. I bought at Radio Shack for $3 and just hook a couple of jumper wires to it and just dial it, look at my scan tool and dial it to where I wanted it to go and see if the fan kicked on. You don't have to wait, you know, if you don't want to. Now, you do want to make sure it's working right, but if you're just checking just nothing but the fan, that's a cool way to do it. Then you got to let it get warm and see if the fan, you know, does kick on. Of course, you are eliminating the PCM, the relays, the fan circuits, and all that kind of stuff, as long as you check your fan with that, you know, roulette thing I talk about with the test light, see if it goes out when you turn it through. Number 4, excuse me. If the parking brake is applied while the engine's running, the daytime running light feature is turned off. That's true. And number 5, the adaptive brake light system selects different levels of illumination for the brake lights depending on conditions. That's true too. Your big TVs, like the one that I got mounted on the wall at the house, whenever the light in the room changes, the intensity of the display changes, you know. Technician A says when a fiber optic indicator is not operating, the cause could be a bend in the cable. Technician B says the cause could be the light source not operating. That's B7. Technician A said solid state circuitry is used in headlight dimming systems to control beam switching. What do you think about that? Technician B says headlight dimming system use mechanical relays to control beam switching. All right. Means high and low beam. Now, what they used to do years ago, everybody in here is car savvy enough and has been around enough old cars to where you've had to stomp a thing on the floor to change the headlights from bright to dim. Okay, now how do they do that? You know, your headlight switch, and this is extremely simplified, is going to go through this little sucker here, and it's basically going to have, it's basically going to be set up so that you've either got bright or dim, you know, depending on which way it goes. You just go, let's say we put that right there and you slide it over here, and you're going to be feeding your dim lights. You slide it up there, you're going to be feeding your bright lights, and it can go either way. Right? That's how that goes. Well, nowadays, in a lot of cases, what you do is when you pull that dimmer switch, what you're doing is you're telling a module, body computer, whatever, or lighting control module, I want some bright headlights. And the lighting control module says, okay, I got a request for some bright headlights. Let's go ahead and give him some bright headlights. And oh, by the way, can you send a signal to the instrument cluster 2 to ask for a bright light indicator? Because the instrument cluster is a computer, the lighting control module is a computer, and all you're doing is like tapping a key on your keyboard. It's a computer input. See, that's not too terribly hard to troubleshoot. Sounds like a nightmare if you're scared of computers, but if you plug in the scan tool, go to the body computer, and you go and it says headlight, you know, dimmer switch, whatever. When you go click, it'll say dim, bright, dim, bright. And if it's getting the signal, then it's going to, you know, tell you that it's dim and bright. If not, I want to go to the wire that's coming out of that, because it's typically going to have 5 volts that'll be feeding in from the module, and it's going to shunt that to 2.5 volts or shunt it to 1 volt or whatever, depending on the system. If you check it, if you back probe it, that wire as your meter, and you see 5 volts and you pull the trigger and it don't change, you know you got a bad switch. See, that's not too terribly hard to do. The engine control part of it, of this electronic stuff, is the hardest part of it. Now, there was one occasionally, I mean, back before they got it to where they could plug in scan tools, I was handed a job on a Eagle Talon. It was brand new. And, well, the problem with this one was it had anti-theft. It had 4 switches. It had a hood switch, a hatch switch, and a door switch on both. And every so often, you know, if it had just the briefest little ground on any one of them switches when that system was armed, it would light off the horn and the headlights for 3 minutes. And so that car was brand new right off the truck, and it'd be sitting out in the middle of the lot, and all of a sudden it'd go honk, 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 honk for 3 minutes, and it would quit. And they said, well, we can't sell that car like that. That'd drive somebody crazy. And so, who gets the job? Well, they throw it at moi, because I'm the, you know, guy that they throw stuff like that at. And so, I said, now, wait a minute. There's no scan tool. There's no trouble codes. Okay, guys, you got to come up with an answer for this.
Jerry rig.
You have to figure out, well, you're not totally wrong, but what I did was I got a little project box about the size of this one, and I've put 4 little red lights on it, and I marked them, you know, right door, left door, hood, and trunk. All right, and so then I got some little straight pins, and I back probed at the connector, and I reading the signal from each. I mean, right there at the little module. The little module wasn't no bigger than a pack of cigarettes, but it had all these wires going to it, and 4 of them were ground inputs from the switches. See, the switch was ground, and it would help if I draw that. See, the little box here was taking ground inputs from 4 switches, and if any one switch, see, it had 4 of these, and if any one switch of them 4 happened to go to ground, even if that wire was shorted to ground or something, it would cause this little module to go crazy and do its little dance, right?
That's crazy.
All right, so this is actually, you know, you got wire harnesses running all over the place, and so basically what I did was I very gently, without piercing the wires, I was able to take straight pins and back probe all 4 of these. Made sure by looking at the book which ones were which, right?
Mm-hmm.
Okay, and then I go in here into my little box here, and I got from Radio Shack, I got some real, very, very weak, you know, 1/10 of an amp fuses or something, you know, whatever the little fuses were, and I wired those little suckers up so that they were connected to power that was being fed from the car's electrical system. And of course I had my light wired up in here, and I'm about to put Sean to sleep over here. All right, so coming out of here, I was wired to each one of those.
Right.
I just hooked those fuses up like they were little light bulbs or something. And I made sure that the thing didn't have any electrical power fed to it until all the doors and the hood and the hatch were closed. Pulled that thing into my stall, had that little box laying in the floorboard where I could see those 4 lights. Those lights were burning. See what I'm saying? In other words, the lights were actually burning. LEDs, they weren't lights, so they weren't pulling any current because they had lots of high resistor and wired series. And what happened with that was, about 6 o'clock that night, some of the guys were still there. They said, that thing lit off last night. I told them, if it does anything, you just leave it alone and let it honk. I don't care if it honks all night. I don't care if it runs the battery down. I don't want this thing left alone. Well, they didn't touch it. Honk, honk, honk. Well, whenever I came in the next morning, it had done that, and the little red light that was feeding that indicated that the hood switch was the problem.
It'd make it blow the light out.
It blew the fuse.
Yeah.
Because that got a short to ground, see,
Right.
and it blew that fuse in that box. So that short to ground, what I did was I put a little watchdog in there that would tell me, hey, it would point my finger at that. And I said, well, that's no problem, because the car, the way it was designed, the little box was right here inside the car, you know, and that little hood switch was right out here. Well, that sounds good, but that doggone wire harness ran all the way over here, all the way up in here, all the way over here, and all the way back over there. I said, that is a bunch of nonsense. Well, there was actually a little bulkhead point right here, and there's a wire harness running straight back this way already going into the car on this side. And I cut that wire, and I cut that wire, and I just went into the loom with a wire and ran it right on into there, and I replaced this wire that made this circuitous route, but it was running inside the loom. You could never tell anybody had worked on it.
On a brand new car.
Brand new car. And rather than pull the dash out and all that crap, what you do is, if you got a wire that you know is shorted and it's buried somewhere and it only goes to one place, why not just do a really good job? I'm talking about a good job, not throwing a piece of yellow wire and doing a jury rig across the engine compartment. But you got to do it where it looks factory. You see, and if you run that wire down through there, get the right size wire and run it down through there, and you solder and heat shrink everything, and you turn that guy up, that problem is gone. It doesn't matter what happens on the wire you've clipped out of the circuit. If you don't clip the wire out of the circuit, though, you're still going to have in trouble. You got that?
Yep.
That's how you fix it, kind of thing.
Full of Sean running over the fender, through the door,
Yeah.
around the steering wheel.
Jury rig this thing here.
All right, but anyway, that's how I did that. And see, the thing about it is, I never had seen anybody do that before, but you got to come up with stuff that works. And that was a troubleshooting
When
tool.
you're good at something, be proud of it. Sean, good Jerry.
Yes,
You
sir.
gotta be proud.
He's
Say it runs in the family.
well, he's actually, well, you know, you got this Army improvise and overcome mentality too. All right. Technician A said solid state circuitry is used in headlight dimming, blah, blah, blah. We already said that. Technician A says fiber optics provide illumination of several objects by a single light source. That's what I just drew up here a while ago. Technician B says light rays travel through the plastic strands by means of external reflections. What in the hell is that? It's going to be A. That's an A. Technician A says to determine the illumination level of the instrument panel lights, the body computer uses inputs from a panel dimming control and photocell. Technician B says using the body computer to control many of the lighting circuits reduces the amount of wiring required. That's both of those guys are right on that. And number 10.
Number 8.
Huh?
I think you skipped number
Sorry about that. Well, yeah, no, 8's what it said. Fiber optics provide illumination for several objects by a single light source. Remember how I drew that thing, that flying saucer on the board a while ago? And Technician B says light rays travel through plastic strands by means of external reflections. Number 8 was actually A. 7 was C. Both of those guys were right. And 9. Technician A says to determine the illumination level of the instrument panel lights, the body computer uses inputs from the panel dimming control and photocell. Blah, blah, blah. 9 is C. And 10 we were going on to. Headlamp doors of a vehicle equipped with computer-controlled concealed headlamps will open but not close. Technician A says the actuator motor may have an open winding. Technician B says the motor brushes may be faulty.
Okay.
Yeah, that's D. Neither one of those guys.
Neither?
Neither. Now, what the deal is, I'm always reminded of the cars in the late 60s. Well, like my 69 LTD that I drove had hideaway headlights on it. And the 69 Cougar had hideaway headlights on it too. And the funny thing about that was they were vacuum operated.
Hideaway headlights are the ones like on this Toyota, right? The ones that flip up.
Yeah.
Yeah, so whenever, you don't even see any headlights unless somebody turns them on. Now, some of your Porsche cars, the headlights lay back like this until you turn them on, then they stand up, then they lay back down for aerodynamics, you know. I mean, you can still see the lights. They don't hide them, they just change the position of them. But occasionally you'll see one of these little Asian cars. I can't remember what kind of car it was. Some of them Hondas had hideaway headlights. And those things would just go crazy, and they start going blah, 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 just flopping up and down, flopping up and down. Somebody pulled up outside the Ford place one day, was pointing at their little Honda car out there, and it was just waving at you with the headlights just flopping around. He said, why does it do that? You know, you'd have to investigate that. 11, you know. I mean, I didn't have any clue why that would happen. I'm sure if we had Identifix back then, we could look it up right quick. Technician A says fiber optics is the transmission of light through several plastic strands that are sheathed by a polymer. Technician B says fiber optics cannot be used for automotive application. Ha, ha, ha. Very funny. That's A. Which of the following is true of the LED light emitting diode? A light emitting diode. Now this is an LED. Now I've told you this before, but the long lead on an LTD is what? Positive or negative?
You want to?
The long lead, it's got two leads. One is long, the long lead is positive on an LED. And if you wire up an LED, you always need to make sure you put a resistor in series with it. Because if you don't put a resistor in series with it, it'll burn it up. And if you put I'll tell you something else too. If you're working a circuit, if you're working with a circuit where you're wanting to put an LED in there and also read a signal, if you don't put a high enough resistor in it, you'll bleed your signal away, too. So, but anyway, that little sucker right there. What I could do, if I had a power source in here, see this little capacitor right here? This little capacitor. This is a capacitor. And you might notice that this capacitor has got a minus on it with an arrow. So this is the negative side of this capacitor. That's actually a short-lived battery. All right. So I can take this and I can hook it to hot and ground for 12 volts, right? All right. And then I could take those two wires and hook this little LED up to that capacitor, and that light would come on for a second. Woo. It wouldn't take it but a second to bleed that capacitor off, but that's what it does. It's just real fast. Now, if you hook the wires up backwards to an LED, it won't even work. Because it's a diode. Now, these little LEDs right here, some of them, and I believe that's what kind this one here is. I could be wrong. I'd have to test it. Some of them, if you hook the wires up backwards, they'll burn the opposite color. I mean, they burn red and green, and if you hook them up one way, they burn red, and the other way, they burn green.
That's pretty cool.
And that's pretty cool. And I need me some kind of I need me some way to, I need to be able to.
Little flat battery.
Yeah, a little flat battery is fun to play with those with and all that. But I mean, I could take a 1.5 volt battery if I could, you know, hook it up fairly easily and just play around with those LEDs. But don't ever hook an LED up straight if you're trying to build something, because you're going to be disappointed whenever it burns out. You know what I mean? And it's no fun to watch it burn out, because it starts out burning real bright, changes color, and goes away, and it never works again. And you're thinking, what a chump I was. You know, but they don't cost very much. Number...
Yeah, once you've got them in where you want them, sometimes they're hard to replace.
Huh?
Sometimes if you're doing something, you get them right where you want them, they're hard to replace.
Yeah. There's ways they got little holders you can snap them into, though. Let's see. Number 12 is actually A. It produces a red, green, or yellow light. Well, it can produce a white light, too. I mean, good grief, look at this one here. That little sucker there is white. It's not this red, green, or yellow. What are they talking about? That's a high brightness LED. You know?
I mean, if you put 160 of them in your computer, make it look cool.
You got it. Lamp outage module provides power to which lights? You ever fool with lamp outage module? All of the above. Technician age. Now, some of these things, all they do, sometimes they'll have a little display that'll tell you that you got a light out, and it basically will send the same signal no matter which light is out. Some of them will tell you if it's a stop light, if it's a, you know, tail light or whatever. All right, number 14. Technician A says the light should turn off after the selected amount of time delay when a bright light is shown into the photocell. Time delay is right. It's going to take about 45 seconds usually for that electronics to do what it's going to do. You know, on the Chevrolet trucks, they have the little daytime running lights. When you back those out into the sunlight and you put them in drive with your foot on the brake, it'll take about 30-40 seconds. Ding, those lights come on. I haven't timed it, but it's less than a minute. And if you put it in park, they go off. If you hit the park brake, if I'm not mistaken, they go off when the park brake's on. And if you got the park brake released, you got it in drive, put on the brake, those lights are going to come on. And it's got a photocell, so it'll know when you're outside. You pull inside, those lights go off and headlights come on.
I got pulled over for no headlights on, but I don't remember my emergency brake being on.
Oh, on your Tahoe, you mean?
Yeah.
Yeah.
I don't know how I didn't have no headlights on.
Yeah, well, you know, I got pulled over one time because I had some tail lights out too. And then I had to fix them right there on the spot. When he saw I was wearing a mechanic uniform, he said, let's see if we can get some lights working on this thing. I didn't even know they were out. And I fooled around under there and jacked around with the fuse panel. They came on and he goes, well, you can make it on like that. All right, he was a nice guy. One time I stopped beside the road because I was driving a little Volkswagen Bug and the CV axle came loose. You know, it's got 6 bolts. Boom, I coasted over beside the road, and I'm trying to work in the hot, trying to start those things with my fingers and all that to get them back in there before I can get on down the road. I don't know why they came loose, but they did, you know. I probably didn't tighten them good enough or something. And there was a policeman that stopped, and he said, what's going on here? I said, well, I'm trying to put this axle back in here so I can get on down the road. I said, you got a flashlight? And he goes, no, I ain't got no flashlight. A cop with no flashlight. Go figure. I kid you not. He said he didn't have a flashlight. He wasn't being a smart aleck. I don't know if his flashlight was dead. I mean, but how you gonna give somebody a ticket if you can't shine a light in their eyes and look at their, you know, you know how you do that anyway. Yeah, he was, you know, he stood. He stayed.
I can't see your eyes, so I might.
Yeah, that's crazy. Yeah, 14. All right, now, let's see. Number 14 is going to be C. Technician B says the headlight should turn on within 10 seconds when the photocell is covered and the ignition switch is in run position. Okay, all of the following are precautions to prevent static electricity damage except what? Except what? What is it? What about wiping the terminals clean? Is that going to prevent static electricity damage? Alright, the low beam headlamps of a vehicle are equipped with a Twilight Sentinel automatic headlamp system are inoperative. High beams are working correctly. Voltmeter connected across the low beam contacts of the dimmer switch shows 12 volts when the low beams are turned on. Technician A says the circuit from the Sentinel amplifier to the dimmer switch is okay. See, that's a kind of a complicated question. If they're going to give a question like this on a test like this, they should draw you a schematic. Just writing this crap out in words and expecting you to internalize that here, You know, number 16, that's basically going to be C. That's both A and B. That is I would not like to have a question like that on no test that I was taking. And I'm going to tell you something else. You will never see a question like that on an ASE test.
It's like one of those graphic questions that's kind of vehicle specific, because it could just be either or.
Do they have any technician ABs on that?
A lot of them. That's why you see so many on here. They got a ton of them. That's like 2 or 3 questions in one. But they love technician A and B. They also love all of these are correct except. You're going to see those too. You know, which of these would not cause blah blah. I mean, you're going to have that stuff. But technician A and B is one of the most common. I'm going to say 50% of all the questions on the ASE test that I've taken, and I may be talking out of my hat, 50% of them are technician A and B questions. And I'm telling you, they love those because it's not a simple multiple choice. You got a bunch of, you better, I mean, the reason they do that is you have to know what you're talking about in order to get past the technician A and B question. You know, you're not likely to guess your way out of that one. All right, now, let's see, all the following, excuse me, low beam headlamps, nope. A vehicle equipped with a VCM, this is number 17, has 2 fault codes stored in memory, B1445 and 1446. After the codes are cleared, the vehicle is driven 2 blocks, and then the VCM is retested for faults code. This time, only a 1446 is stored in memory. Which of the following statements are true? C. B1445 is a history code and 1446 is a current code. Whenever you're checking codes, the smartest thing you can do, rather than go diving in there trying to fix all the codes, is clear the codes and see which ones come back. Because some of them are kind of spurious. They may just pop in there and not mean anything for whatever reason, or they may be something that's really, really, really intermittent. So anytime you're working with trouble codes, write down what they are, clear them out of there, try to duplicate your similar conditions, whatever they may be, you know, and see if the code will reset. That's the smartest thing you can do. The interior lights of a vehicle equipped with an illuminated entry system stay on even after the ignition switch is placed in the on position. That's not supposed to happen. Illuminated entries, when you open the door, you close the door, this light's still on, you turn it on, they go out. Usually they'll dim and go out. Well, what if they stay on even after you turn on the key? They're not supposed to do that. Technician A says the input signal from the ignition switch may be open. Technician B says the entry module may be faulty. Now, either one of those guys can be right. So that's going to be a C there. And we're getting close to the end here. We got 2 more questions.
They ask a lot of questions on those ASE tests. What is a code, P, whatever, or...
They don't expect you to have that stuff memorized. Unless it's a super, super common code. But you almost never see that. Everybody knows misfire codes are like a P0301, P0302, P0303. I mean, anybody that's done any kind of work on a OBD car knows that. But you very seldom see specific codes. They're very fair on those ASE tests. They will show you a schematic. They'll say, if I measure this at point A and this at point B and this at point C, then what's my problem? And a lot of it, if you just sit there and think about it, you can figure it out. But there's other things, questions, like when I took that light vehicle diesel test, you cannot wing your way through that one. In other words, it's really hard to wing your way on any of those. But if you've been hitting these books, and you've been doing this studying, I mean, these books that, you talk about ASE study guides, the books that you've got are some of the best ASE study guides there are. Because if you get to where you're well versed in what those books say, you will sail past that ASE test. I mean, because they're actually structured to prepare you for the ASE test, and they give you a lot of detail that you won't get in just a basic ASE study guide. A lamp outage warning system is indicating a lamp failure. All of the vehicle lamps are working, but one of them, the left rear tail light, appears to be dimmer than the rest. Technician A says the light bulb may be mismatched. Technician B says excessive current resistance may exist in the right rear tail light circuit. That's basically A. If you have, the lamp failure system is typically going to measure the current flow to that lamp. And if you got a lamp that's not the right one, and it's not burning as bright, you're going to, have a lamp failure thing. Technician A says the Photocells should be replaced if the lights don't turn on within 60 seconds when the resistance assembly switch is in the off position and the ignition switch is in the run position. What a question is that. Technician B says it ought to be replaced if the lights turn off, blah, blah, blah.